functions today. So still in lesson 1.3. Yesterday we looked at, okay, how do we take an equation, a piecewise equation, and put the pieces on the graph? How do we graph it? This one, we're doing just the opposite. Okay, there's the graph. We have to write all the pieces. So when we do this, we're going to make it look like what was given on the front. So we're going to do this piece by piece. I'm going to go ahead and set up my answer, as I'm going to use f of x. And I'm going to set up that big brace. I think it's called a brace officially. Because notice, how many pieces of the graph are here? There's 3, yes? So we're going to need to have 3 equations with their restrictions. Okay? So I'm going to go ahead and set that up now. Pick one, right? Well, I would say it doesn't matter which one you begin with. It doesn't matter technically which order you put them in. Okay? They would be equivalent. And I don't think Savas, Math Excel, I don't think they would count you wrong if you put them in order as long as your pieces are correct. But generally you will see they tend to go left to right. So, we use this one right here. We need to know what equation that is. Now, what's the form of a line that we often use? What's the equation for a line that we like to use?
X plus H.
No. Equation of a line. We used it yesterday. What?
Y equals mx plus b.
Yeah, y equals mx plus b. So we're going to be looking at y equals mx plus b for all of these. Now, in order to talk y equals mx plus b, as we look at the line I just kind of colored in purple there, can you tell your y-intercept right now? Technically, no. But how can I figure out where the y-intercept would be if I extended that line?
You just keep going.
Yeah. You know how I did all those tons of dots yesterday? Could we do the same thing today?
Yeah.
Yeah. And this would be the benefit of, okay, I can see these, and it looks like, as we do this, it's an up 1 over 1, isn't it?
Yeah.
Or so in this case, when we're trying to figure out, we're going to go down 1 over 1, down 1 over 1. So if we're extending that line, it's going to go through the y-axis at
0, 0,
0.
0.
Okay? What's our slope here? If I rise over run, we're going to rise 1 the way I just did it, so up 1, and then we're going to go left 1, which is negative 1. And what is 1 over negative 1? Negative 1. So I have a slope of negative 1, and I have a y-intercept of 0. And again, if we're going for that form, that was really sloppy there. What is that equation going to be? Y equals, okay, negative 1x plus 0, which what do I write that as then? Negative x. We don't usually write the 1, the invisible 1 in front of an x, and we don't need to write a plus 0. So the top line I'm going to put right here, f of x equals is equivalent to the y equals. So the only piece I need to put is the negative x. But, comma, what are the restrictions on x here? Because is this the full line y equals negative x?
No.
No, it's that little itty bitty part of it. So think like yesterday, from what x value to what x value are we using here? Yeah, so if you line them up, yes. I agree, negative 2, negative 3, or negative 3, negative 2. So we usually put the smallest one first, x in the middle, the larger one last. When you write the sentence like this, the compound inequality like this, we use both less than signs. Okay? Because technically what we're saying here is it's less than -2, but greater than -3. What are you going to tell me? Or are you
You
going to
gotta put the equal to under the -3 to the x.
Okay, and the part that I was going to go to next, do either of these need equal to's under them? At -3, it was filled in. So I need an equal to under there. -2 was not filled in. Okay, we got a third of it done. Again, you can go quicker on your own once you figure this out. So I'm going to go for the next one now. Okay, color coding like yesterday. That way I can just refer to the color. So I'm going to talk about that green one. That green piece is a what? Horizontal line? What do horizontal line equations look like? It's a horizontal line, it's just y equals whatever that y value is. So y equals a number. What is the y value here? It's a 1. So we're just going to use y equals 1, which means if it's f of x equals, all I have to put here is 1, comma. I need my restrictions, because it's not the whole entire line that goes on infinitely. It's just that one little piece. So where does that one little piece start? At -2, less than x, less than, where does it end? The x value of 1. Do either of those need equal to's? Landon?
The -2 does.
-2 was an included filled in circle, so we need the equal to. And please, stop me if you have a question, okay? If there's a question that comes up as I'm going over this, stop and ask. Okay, last piece. Hey, you know what? If I go orange, I don't even have to color the last piece. There we go. We'll go orange. Well, got a line again, right?
Yeah.
So we probably need to go in that form y equals mx plus b again, yes?
Yeah.
I guess I could have been doing all this scratch work kind of over here. Realize this stuff off the left, it's just kind of my scratch work, isn't it? It's not stuff that you have to have. It's just me thinking out loud. But if I go, okay, think y equals mx plus b here. Do we know that y-intercept? Actually, let's go with what's the slope. That's probably where we need to start. What's the slope of this line? Okay. It's a rise 4, run 1, which is a slope of 4. Now, what's that mean I need to do to find my y-intercept? If that went up 4 over 1, then we're going to need to go down 4 over 1. Where does that make my y-intercept? -5. So we would normally say y equals 4x minus 5. So down here, only piece I need to put is the 4x minus 5. Okay. Can you think to that? Can you be that step ahead of me? You know what you're doing for your x values? You need to know where this piece and this piece are. What x values are they lined up with? 1 and 2. X in the middle. They both appear to be less than signs because this is when x is less than 2. X is greater than 1, but we have it flipped. Equal to's? On both. Even better, we agree with my answer key. So I agree with myself from yesterday. That's good. Okay. I don't know. That wasn't any worse than graphing it, was it? I was afraid that was going to be worse, but I don't know. Some of you guys don't seem to be minding this. Some of you are probably hating it, so not sure what to expect. Okay, let's try the next one. I'll set up the basics. F of x equals, and I don't know on Savas, I'm guessing they're already going to have this set up for you, and you just have to fill it in. I honestly don't know, unless it's multiple choice and you just get to pick which one it is, which that might be an option too. Okay, I'm going to start with my piece farthest left. Oh, well, it'll come out here in a moment. We have a horizontal line, yes. Horizontal line is just y equals a number. Are you getting that stuck in your head? We keep doing that, right? So that's a good one to remember. So what is this line? 7? Beware of the scale on this one. It's tricky. I didn't realize till after I put that graph on there how tricky the scale makes it. So just beware that they're counting by 2s, aren't they? Okay, so right here, this is at 7. It's y equals 7 is our equation. Not having looked ahead, I had no idea why you were saying -5. Okay. Okay. What are the boundaries? Okay. What's the domain on this piece? It goes from, Gatlin's calling that -5 to -2. Remember, when you set up a compound inequality, as long as you have a bigger number on the right, smaller number on the left, they're both less thans. Any equal to's? Both are equal to's. Next. Okay, green line. What do you see? We've got to go back to our y equals mx plus b. What's b? B is 5. Okay. What's the slope? This is where I don't like the scale because it makes it a little bit more awkward to count, but it's still doable. Guesses on the slope? What? There's a couple different ways we can look at, okay? Obviously, if this graph is counting by 2's, yes? So what are the halfway points of boxes? They are 1's, yes? So you could look and say, okay, like right here, I'm going to go down 1 over 1 to get to that next piece here. Or I could look like from here over to here, I'm going to go down 1, 2, 3, and over 1, 2, 3. So there's different ways to count that. You do have to be careful. But one way or another, the slope is -1. So my equation is going to be -x plus 5. On what x values? Okay, it connects with the last piece at -2. And it goes over to, what x value is this? 3. equal to signs. Yes, no, where?
Both.
Okay, so let me comment on the both. I will say there's definitely one with 3. The both. If I look in the answer key right now, like when I was checking my answers to make sure, because this is a problem I took from the book, they did not have an equal sign here. Now, why? Because it overlaps the other one. And since these are the same point, what this is saying is that you only have to have the equal to one place or the other. Now, in my opinion, you wouldn't necessarily have to have it here. You could instead have it here. I personally don't see what's wrong with having both places, but I'm not sure if that's technically acceptable. That's a little bit of piecewise functions that I've never really encountered that question, so I'm not sure. Okay, so me personally, if I'm grading something for you, I'm going to accept either or. Now, if you're putting something into the computer, what's the computer going to accept? I don't know. I don't know how flexible the computer is. Okay, so that's what they did on that one. Okay, last piece. An angled line, so again, let's think y equals mx plus b. Well, before we try and find the y-intercept, I should probably try and find the slope. Thoughts on the slope? If I count from here, this is at a halfway point, right? So this is, up to this line would be 1. Middle is 2. There's 2, 3, 4. Could we agree with a rise of 4? And then a run of 2? So I would say a slope of 2. I know, it's difficult to count here, isn't it? But so a slope of 2, and if you want, for the next set of counting purposes, you could think 2 over 1, right? Because when we go to count down and find our y-intercept, you can count down 4 over 2, or you can go down 2 over 1. Either way. Did you guys figure out where we're going? Oh, I messed that up already, didn't I? Gosh darn it. I was going the 4 and 2, so I was counting down 4, which means I then need to go over 2. 1, 2, 3, 4 over 2. You guys agree with that?
Yeah.
Hey, I agree with my answer key. Even better. Okay. So, y-intercept being -3. So, this equation is 2x minus 3 for what x values? 4 to 6. Equal sign on the 6. Yes?
How did you get -3?
How did I get -3?
Yeah.
Like how?
Okay, so answer it for you too.
I got -2.
Yeah, I got
4.
I do have -3 in my answer key. Okay, let's double check it then. I was kind of letting them explain back there, but let's make sure, because this is my first year through these notes. I kind of messed up too. So, okay, so if I'm going here, the first time I did, I counted 4 over 2. If I use my slope of 2, it'd be what? Down 2. So if I go from here, here's 1, 2 over 1. Down 1, 2 over 1. Down 1, 2 over 1. Down 1, 2 over 1. I still agree with -3. I agree with them in the middle of the box.
I got it. You have to go to across the line.
Okay. So it sounds like a slightly different issue. I don't know. And this is where this one's more complicated because of the scale, isn't it? So you do have to be careful. Okay. Do we have the basic idea? Well, we may not agree on my -3 there, but we know the idea of what we're supposed to be doing, right? Did you figure out where you? Okay. Let's look at a word problem. Okay. Yes. Definitely. Yes, by all means, make sure you get everything you need, right? Okay. Okay. In words, we're in a piecewise function lesson, yes? So we're going to put it in word. We're going to put it as a piecewise. A phone company offers a monthly cellular phone plan for $25. The plan includes 250 anytime minutes and charges 20 cents per minute above 250 minutes. Write a piecewise defined function for C of x, the cost for using x minutes in a month. So, notice they asked me to use C of x and write a piecewise defined function, yes? And they're telling me to use x, and what does x represent? Minutes. Okay, so C is cost, x is minutes. There's pieces, because the cost of your bill depends on what? Minutes, right? How many minutes you use. What's one option? Your bill could be a flat, how much? $25. When can my bill be $25? Okay, so 250 minutes or less, which means if we set this up like we were doing up above, I put X in the middle, 250 minutes or less, but it has to be more than how many minutes if we want to get technical? 0. I mean, all honesty, if you put X less than 250 there, I would take it. Now, which way does 250 go? In other words, do I need an equal sign on 250 here?
Yeah.
The plan includes 250 minutes. So this is less than or equal to. Okay? So that's one option. We all want that $25 cell phone plan, right? I wish. Now, after 250 minutes, what happens? 20 cents per minute. Do you still have to pay the $25?
Yeah.
Yes.
Yes. So how do I write an equation representing that? How do we write that equation? Okay. Okay. So he said 20 cents x plus 25. As in, I'm taking 20 cents and multiplying it by x to get the price extra per minute I'm being charged and adding on to the original 25. Now, when is the only time I use this piece of the equation? Yeah, when my minutes are above 250. So in this one, I'm just going to say x greater than 250 because we don't have a max. It's not like it's saying if it has to be under something, Okay. You did a word problem. Okay. One last piece here.
Can we do this first?
This one?
Yeah.
You can try it. I don't get. You can. You're always welcome to try them by yourselves. This one is a little bit different. It's still a piecewise function, though. It just has a special name because it's called a step function, which will make 100% sense once we have the graph of why it's called a step function. But it's still piecewise. So this table represents fees for a parking lot. So if you're parked 0 to 3 hours, you pay $10. 3 to 6 hours, you pay $15. So on and so forth. They want us to graph this. And we want to talk about the domain and range. Okay. Do you see how to graph it? What's the first piece here? From 0 to 3 hours, my cost is $10. How do I graph that?
You go up to the 10.
We go up to a 10,
You draw a circle,
draw a circle,
and then you go over 3.
then we go over 3,
And then you put a color circle.
and then we put a colored circle. His words. Does that make sense? That graph is showing that from 0 to 3 hours, which 0 to 3 is down here on my time axis. I just realized this is going to be our cost over here, right? And this is our time here. So from 0 to 3, it's $10. It's a flat cost. Then what happens? Now it bumps up to 15. So at 3 hours, find your 3 and bump up to 15. And so from 3 to 6, it's 15. And like last time, the right-hand point is filled in. Can you keep going? Mm-hmm. Go up to 20. That goes from 6 to 9 on the 20 line. It's not equal at 6. It is equal at 9. And then, if you're there all day, you're going to pay 25. Again, from 9 to 12 is 25. I goofed that up. I'm going to blame, because I'm on the BenQ, I'm trying to stand off to the side, and I sometimes get messed up on which line I'm on. There we go. I had bumped over a line. Is that better? Okay. That's called a step function. It's also a piecewise function, but do you see why it might be called a step function? Now, these steps aren't connected. They're just hanging out there. But it's a step function. Thoughts on the domain? Normally I would say, okay, what x values did we use? In this case, it's not exactly x, it's t. What's the domain of this problem? 0 to 12?
Yeah.
Are all of the numbers included along the way?
Yeah.
Well, not 0. Is 3 included?
Yeah.
Yeah, because it's included here. Not here, but it's included here. 6, 9, yeah. Is 12 included? Yeah. So if I write this in interval notation, it's 0. My interval starts at 0. It ends at 12. Parenthesis on 0 because it's not included. Bracket on 12 because it is included. Range.
Yeah.
10, 15, 20, 25. What about the numbers in between? Here, it's the y's for this first piece are at 10. All of them, aren't they? All the Y's for the next piece are at 15, 20, and 25. So this is one of those, like yesterday, where you list them just with commas. It's 10, it's 15, it's 20, and it's 25. You can either just list them with commas like that, or instead of using parentheses or brackets, it's the squiggly marks. Okay, the braces. Okay, guys. You got a little bit of time. I would suggest you use it. Okay? You can get a little bit of work done. If you've already started, you might be able to come close to getting it done. I don't know. Okay? See what you can do with it.